Alright, so let's proceed to problem number 5. So again, basahin natin. So water is being pumped from a reservoir to air, and then water inside the reservoir is maintained at elevation -1 meter. So the center line of the pump, so ayan, meron na tayong pump na i-consider dito, is situated at elevation 0.5 meters and the discharge point is at elevation 10 meter above. So guys, from this given, so i-drawing muna natin since medyo mahaba-haba yung ating problem. So sabi diyan, yung pump mo daw is humihigop ng tubig from a reservoir. So assume natin na ito yung reservoir mo. Ayan. So dito meron kang suction pipe o suction line na nagdraw-draw or humihigop ng tubig. So, papunta sa pump. So, ang goal nga ng pump mo is to transfer water from a higher point. So, usually, ang symbol ng pump is ganito. Ayan. And then, oops. Tapos, sige. Shoot. Okay. So, unahin muna natin yung mga elevation na. So, sabi dito, yung elevation ng reservoir mo o yung water surface level here is given as -1 meter. And yung center ng pump mo, so, ito. So, ang elevation ng pump is given na 0.5 meters. Ayan. And the discharge point, itong discharge point na to. So, ito yung suction line na. Dito nanggagaling yung tubig. And then ito is the discharge line. Magabok. Discharge line. So, ang elevation nito is given as 10 meters. Excuse lang. So, ituloy natin. Medyo magabo kasi dito. May mga ginataas. The suction line is a 75mm diameter HDPE pipe. So, ito. Naglagay siya ng type ng material na ginamit. So, most probably, may i-specify niya yung mga head losses sa bawat connection ng pipe niya. So, ito daw suction line. So, ang diameter daw nito is, so sabihin natin, ano gusto niyang gawin natin. So, let's just say na ito is 0.1. Magsaset na tayo ng point na papangalan natin. So, ito is D1, which is equals to 75 mm diameter. Or tawagin na natin na 0.075. I-convert ko na siya. And yung discharge line mo is a 50mm diameter na PVC pipe. So, ito, pangalanan na natin to as 0.2. Kung saan yung diameter dito, or yung D-sub 2 natin, is equals sa 50mm. Or, yung kumulubog. 0.05 meter. Alright. Ayan. So, the head loss from the water surface, so dito sa reservoir mo, up to the pump. So, maglalagay ulit ako ng panibagong point dito. So, up to the pump. So, siguro ito yung moment before siya pumasok mismo sa pipe. So, let's say na ito is 0.8. Kate. Wala ang COVID. So, the head loss from 0.1 hanggang A. Ano yan? Wala. So, the head loss from the water surface of the room is 850 mm. Or that is equals to 0.85 meter. While the head loss from the pump, so ito, siguro sa makalabas siya after ng pump. From the pump up to the discharge point is 900 mm. So that is the point from point B to 2. So 900 or 0.9 meters. Wait. Okay. So what is the pump's power rating if the efficiency of the pump is 70% and the system flow rate is 100 gallons per minute? So in GPM is gallons per minute. And also, we need to determine the pressure at suction line before entering the pump. So ang pinapahanap yung pressure is dito. So pinapahanap rin yung pressure at A, pero ang unang pinapahanap is yung pump's power rating. So again, ano nga yung ating dito? Di ba yung hydraulic power or yung pag-pump, di ba ito yung heat added? So yung power na mahanap nating una is yung P out. Ano? Again, ang ating power, ating equation for efficiency is denote ko na lang siya SF. Efficiency is equal to P output over P input. So times 100. So ang una nating mahanap, di ba yung equation natin sa power is Q gamma HA. So ito is yung ating P out. So, ang pinapahanap po dito sa problem is yung PE natin. Okay? Okay. So, analyze muna natin siya. So, again, ano ba yung pinakamagandang point na i-consider dito kapag gumawa tayo ng Bernoulli's energy equation? Tama. So, from point 1 to point 2. Kasi sa point 1, so di ba ito is reservoir? So, ibig sabihin malaking container niyan kung saan yung velocity head mo or yung V1 squared over 2G will be equals to 0 na. And at the same time, since yan ay, ano ba siya? Di ba exposed siya sa air? So, ang pressure head mo dito will be also equals to 0. And, ano pa? Ang magandang isip. So, sa point 2, as much as possible, wag kang papasok, wag kang titigil sa loob ng pipe system. So sa point 2 or the discharge point, so since nasa labas na yan or bumubugan na dito yung tubig mo. So sa point 2, ang meron lang dyan is yung velocity head. So V sub 2 squared over 2G. Yung pressure head mo, since naka-expose na ulit siya sa so that will be equals to 0. And given naman yung mga elevation head. So both from point 1 to point 2. Pero since pumasok siya doon sa loob ng pump, so if consider mo yung mga head losses. So, given naman sa problem, at the same time, yung heat added mo. Okay, so ano yung equation natin dito? So, our equation again. So, by applying BEE, or the Bernoulli's energy equation, from point 1 to point 2. So, our equation will be the total energy at point 1 minus the head loss, or the head loss from point 1 to point 2. And then plus, so plus yung heat added is equals to E sub 2. Okay? So, I think we can now apply the BEE. So, unahin natin yung point 1. So, again, yung velocity head mo is equals lang sa 0, also the pressure head. So, ang isasama mo na lang dyan is yung elevation head, which is negative 1. And then minus yung summation ng iyong head losses from point 1 to point 2, or that will be 0.85 plus 0.9 meter. And then yung plus HA, or the heat added, so ito nga yung pinapahanap muna natin, or yung hinahanap muna natin sa problem, is equals to the velocity head at point 2. So ano ba yung velocity head natin dito? Ayan, so nagbigay siya ng flow rate doon sa ating 5 gallons per minute. So we need to convert this to cubic meter per second. So ano ba yung conversion natin for gallons? Okay, so sabi dito, ang conversion mo ng gallons is, so convert muna natin yung yung Q. Yung Q sub 2. So, you have here 100 gallons per minute. So, ang conversion ng gallons mo, so we have 3.7854 liters in 1 gallon. So, cancel out na natin itong gallon. And in 1 liter, in 1 cubic meter, there is 1,000 liter. And yung minute, i-convert natin to seconds. So, in 1 minute, we have 60 seconds. So, the equivalent value of Q sub 2 is equals to 1. So, pindot na naman sa RQ. So, 100 times 3.7854 divided by 1,000 and then divided by 60. So, that is equals sa 6.309. So, times 10 to the negative 3 cubic meter per second. And para makuha natin yung velocity niya sa point na yun, so i-ano lang natin siya, convert din natin. Or alam natin na yung Q is equals lang sa A times B do sa point 2. Or that will be equals lang, so copy mo lang to. So pi over 4, so ano ba yung diameter natin dito? Ayan, discharge line. So 50 mm diameter. Or that is 0.05 squared, and then yung pinapahanap, which is the B. So what is the velocity? Times 4 divided by 5 divided by 0.05. So nakuha ko is 3.2131 meter per second. Alright, so pwede na tayo bumalik dito. So, punta na tayo sa velocity head at point 2. So, we have now the velocity. So, 3.2131 squared all over 19.62. So, again, yung pressure head mo dito is equal to 0. So, elevation head. So, given naman sa problem, plus 10 meter. Plus 10. So, from that, mahahanap natin yung heat added niya. So, papindot lang sa RQ. So, yung velocity head, 3.2131 squared divided by 19.62 plus 10. And then, transpose mo sa kabila, yung negative 1, so magiging plus 1. And then, i-plus mo rin yung head loss. So, plus 0.85 plus 0. So, nakuha kong answer for the heat added is 13.2762. So with this, we can now compute yung ating P output, which is Q gamma of H A. From where? Ano ba yung value natin ng Q? So given naman ulit nga dyan na equals ito nga. So ito yung conversion natin. Ito, 6.309 times 10 to the negative 3 cubic meter per second. So maganda guys, pag-aralan yung mga store. Pwede mo itong store in any value doon sa calc. Pwede A, B, C, so on. Q times gamma. So wala naman sinabi kung anong klase yung tubig siya. So malamang water. Ito pala water. So automatic 9.81 lang siya. So it is kilonewton per cubic meter. And then times yung heat added, so which is 13.2762. So our answer for this will be equals so answer times 9.81 times Q na 6.309 times 10 to the negative. So, ang nakuha kong power output is equal saan? Ang nakuha ko ay verify ko. 0.8217 ang unit niya is in kilonewton meter. So, newton meter is joules. So, kilojoules per second. Or, equals lang din siya sa 0.8217. So, joules per second is equals ka sa kilowatts. Okay, so usually ang mga unit mo naman for a pump is in horsepower. So i-convert mo lang siya to horsepower. So alam natin ang 1 horsepower is equals lang sa 746 watts or that will be 0.746 kilowatts. Okay, so again guys, pa-review ako ng mga conversion na yan. So baka dyan tayo magka-problema kapag di ka masalos. Divided by 0.746. So ang answer ko is 1.1015 horsepower. Pero hindi pa dito natatapos ha. So again, ang kailangan nga nating hanapin is yung pump's power rating. O ang pinapahanap talaga dito is yung power input. Okay? Kapag sinabing pump's power rating. Kasi nga yung P out dito is ito yung power mismo ng jet, yung na-produce na jet. Kung saan ang kino-consider dyan is yung kitado. Pero ang kailangan mo talaga is yung input or ano ba talaga yung power rating ng pump. Okay, so para makuha yung P input, so dito ko na lang isulat, balik tayo dito sa pula. So para makuha ang P input, so that is equals lang saan? So P input is equals to do sa output na 1.1015 over the efficiency na 70%. So times 100%. So what is the P input? Answer divided by 70 times 1. So our answer is 1.5735 horsepower. So ito, pwedeng sagot na to. Pero in actual guys, check mo na lang din sa market kung ano yung mga usual design ng pump. So hindi mo naman siya pwedeng i-round down kasi baka merong pipe na 1.5 horsepower parang aircon. So dapat pa-round up ka dito. Or most probably yung kailangan para ma-design mo properly, okay lang lumabis to. So, mga 2 horsepower, safe na yan. Safe na to. Pero na exam and board exam, ito na yung sagot natin. Okay, so ang sunod na pinapahanap is yung pressure daw dun sa suction line before entering the pump or yung pressure niya at point A. Okay? So, ang gagawin lang natin, so, pag-isiksi ko na lang dito guys since limited lang talaga yung space natin. Okay, so para dito sa letter B, so paano natin letter B? Mag-a-apply ka lang ng BEE or Bernoulli's energy equation from point 1 to point A. Okay, so kung point 1 to point A yan guys, so ibig sabihin hindi siya pumasok sa pump, so wala ka magiging heat added. And ang i-consider mo lang head loss is yung from the suction line hanggang sa bago sumapit kay point A or itong head loss from point 1 to point A. Okay. So again, yung equation niya is yung total energy at point 1. So minus yung head loss from point 1 to A is equals do sa total energy at point A. Okay, so again, at point 1, wala tayong velocity head and wala tayong pressure head. So the only existing dyan is yung elevation head niya, which is negative 1 meter. And then minus the head loss from point 1 to A, so minus 0.85. Is equals sa velocity at point A. Right. So guys, kung mapapansin nyo, di ba magkaiba yung ating diameter ng mga pipe. So yung flow na dumadaloy dyan is 100 gallons per minute. So, para makuha yung velocity niyan, so idiretso ko na lang din dito guys. Di ba ang ating equation is para kay velocity ay kung ang Q is equals to A times V. So to solve for V, that is equals lang sa flow rate over the area. So isulat ko na lang dito diretso. So ang gagamitin ko is yung naka-convert na, yung 6.309. 6.309 times 10 to the negative 3. So divided by, pi over 4, pagkasyahin nyo na lang, times, anong diameter ng sa point A? So, times 0.075. Square. Ayan. So ito is velocity pa lang ha. So di ba b squared over 2g. And then naka-squared pa siya over 19.62. So alam ko gets nyo naman to, di ba? Ang kinuha lang natin is yung velocity at point A. So hindi mo to pwedeng gamitin ha. Kasi ito yung velocity niya dito sa point na to, sa 2. And again, magkaiba yung diameter niya. So dito sa point 2, 50 mm, dito sa point 1, 75 mm. Magkaiba yung diameter ng dalawang pipe na to. Okay? So ito siya. So again, that is yung discharge na 6.309 times 10 to the negative 3 cubic meter per second, and then divided by yung area ng pipe at this suction line. So si velocity, in-squared ko siya over 19.62. Okay? And then plus the pressure head at point A. Ito nga yung hinahanap, yung divided by 9.81. And then plus the elevation head at point A, which is kapatay lang naman ito. So that is 0.5. So the pressure at point A will be equals lang sign. So pindutin lang natin. So tra-transpose lang to sa kabila. So negative 1 minus 0.85 minus yung sa velocity head. So the quantity of 6.309 times 10 to the negative 3. So divided by the quantity of pi divided by 4 times 0.075 squared over 19.62. And then minus 0.5. So times mo lang ng 9.81. So ano po napindot nyo? Sige, hintayin ko kayo. So nakuha kong sagot kasi is 24.7066. So yun rin ba yung answer? Okay, so isulat lang natin. So paki-update na lang ako, pero ang sagot ko ay 24.7066 kilo Pascal. Alright, so guys, since negative yan, so this indicates na yung pressure natin at this point is a suction or pahigop siya. Pressure is suction or pwede natin tawagin na vacuum. Alright, so let's proceed with the next problem. I think this is the last problem yung sunod.